All right, today's lesson was on trigonometric proofs. There are a variety of techniques that can be used in order to complete trigonometric proofs. The first one being factor out a GCF or just regular factoring. The second one, FOIL or distribute. The third one, getting common denominators. The fourth one, breaking apart fractions into two or more fractions. And then finally, once you actually do all those algebraic properties, you can use reciprocal, quotient, and Pythagorean identities. Okay, so we have our first example here, says verify the identity. So what we're trying to do is we're trying to prove that the left-hand side, which looks pretty complex right now, is equivalent to 2 secant of x. You cannot manipulate the right-hand side of the equation. You can only manipulate one side of the equation. So on this left-hand side, if we look at all of our different techniques, because we have two fractions here that are being added, we could get common denominators as our technique here. So if we want to get common denominators, then that means I need to multiply the first fraction by cosine, and the second fraction by 1 plus sine. That way they have common denominators. Like so. So that means their common denominator would be cosine times 1 plus sine. And on the numerator, we have cosine times cosine, which is cosine squared, plus, if we FOIL this out, this is 1 plus sine times 1 plus sine, first outside, inside, last. That'd be 1 plus sine, which is 2 sine, and then sine times sine, which is sine squared. Okay, so if we look at our numerator and you think about your Pythagorean identities, we have cosine squared plus sine squared. Remember that cosine squared plus sine squared is equivalent to 1. So I can plug in the fact that cosine squared plus sine squared is 1. Therefore, my next line would be 1 plus 2 sine of x all over the denominator. And then if I combine like terms, you know that 1 plus 1 is 2. So that means that we'd have 2 plus 2 sine of x all over the denominator. And then finally, look at the numerator. You could factor out a 2 because that's a GCF. And now we have 1 plus sine and 1 plus sine on the numerator and denominator. So that means that we can cancel that out. And so if you're left with 2 over cosine, if cosine's on the denominator, then we could take the reciprocal of it. The reciprocal of cosine is 2 secant, which is what we wanted the right-hand side to equal. Okay, so I just proved my first trigonometric proof. We got the left-hand side to be equivalent to the right-hand side, which was 2 secant of x. Now let's look at a second example. If we think about our trigonometric techniques up there, this one looks like I could FOIL, first, outside, inside, last, or box method, however you like to do things. So if I use my FOIL method, since that's what I could algebraically do to simplify the left-hand side, cotangent squared times sine squared is cotangent squared sine squared. And then 1 times sine squared is just sine squared. And then my outside cotangent times 1 is cotangent squared. And then 1 times 1 is 1. I'm trying to make this equal the right-hand side, which is cotangent squared plus 2. Right now I have a cotangent, so I don't want to touch that at all. So I want to look to see if there's something I can simplify. If we look over here at the cotangent times sine, I could change cotangent to cosine squared over sine squared. And if we do that, notice the signs cancel out. So that means I'm left with cosine squared x plus sine squared x plus cotangent squared x plus 1. And then remember, cosine squared plus sine squared is equal to 1. So that means I have 1 plus cotangent squared plus 1, which is cotangent squared x plus 2, which is what I want my right-hand side to equal. So when we look at our techniques, this technique, we wanted to use the FOIL method since that's algebraically what we could do. So in the previous one, we could do common denominators. So we got common denominators, okay? Now let's look at example number 3. In example number 3, we have sine times cotangent plus cosine tangent. If we look at all 5 of those techniques, we could distribute that sine. So that's why you want to kind of refer back to the techniques to see, okay, can I factor out a GCF? No. Can I FOIL? No. Can I distribute? Yes. Can I get common denominators right now? No. Can I break up? So the only thing we can do right now is distribute. And so then if we look the right-hand side, we want it to equal cosine plus sine squared. So I need to get things in terms of sines and cosines. So what I'm going to do is I'm going to change that cotangent to cosine over sine. To cosine over sine. And notice that the sines cancel out. So I'm left with cosine of x. And then over here, I have sine times cosine times tangent. Tangent is sine over cosine. So the cosines cancel out in this case. And so I'm left with sine times sine, and sine times sine is sine squared. Okay, so this one I distributed. All right, in my 4th example, here I have tangent minus cotangent all over sine cosine, and it's equal to secant squared minus cosecant squared. So what I could do here, since I have 2 things that are added or subtracted all over a denominator, I could break apart the fraction into 2 or more fractions. And then I could change that tangent to sine over cosine. And it's all being divided by sine times cosine over 1. So I could flip that and make it 1 over sine cosine. Minus cotangent, I could change to cotangent or cosine over sine. And same thing, that fraction is sine cosine over 1. So if I flip, since it's a fraction divided by a fraction. And then sines cancel out here, and the cosines cancel out over here. So that means we're left with 1 over cosine squared and 1 over sine squared. Well, according to our reciprocal identities, 1 over cosine is cosecant. 1 over cosine is secant, so secant squared. And 1 over sine squared, the reciprocal of sine squared is cosecant squared, which is what we wanted. Okay. Now, in our final one, this says cosine minus cosine sine squared x equals cosine cubed. So if we look at all of our techniques, we could factor out a GCF here. We could factor out the fact that they both have a cosine in common. And if we take out a cosine from a cosine, we're left with a 1 minus cosine from a cosine sine squared is sine squared. And then if you think about your Pythagorean identities, 1 minus sine squared is cosine squared. And if we think about our exponent properties, cosine times cosine squared would be cosine cubed. So that's how you prove trigonometric identities. We use the reciprocal identities we know, the quotient identities, the Pythagorean identities, and you want to think about the techniques, factoring out a GCF, FOIL, distribute, common denominator, stuff like that.